Screen is visible. Screen.
Yes, sir.
Yes, sir.
Okay. So neural networks is the topic. Uh, वो रहता था हमारा. So neural networks आप लोग familiar हैं ये कि what was this basically? It is the way how the humans learn and how the basically the brain structure is there, how the brain works. Basically the main component is their neurons and which are connected to other neurons and which are responsible for the decision making process in the human. So this is the neuron thing which is there in our brains, and these are basically responsible to for receiving the electrical signals, and then they also propagate these signals to the other connected neurons in the network, and this way the information basically flows. So this is like how the one neuron is connected to the other neuron and makes a huge network of flowing information in our brains. So the neurons, they are connected to and receive the electrical signals from other neurons, and these process the input signals and can be activated. So आप लोगों को थोड़ा जनरल फैमिलियरिटी तो होएगी कि आपने बायोलॉजी के में पढ़ा होगा कि हाउ द ब्रेन्स आर बेसिकली स्ट्रक्चर्ड. ह्यूमन ब्रेन्स follow up their working. Neurons basically make up the basic component in the human brains that are responsible, whatever the humans are perceiving, whatever the humans are sensing in their environment. So this information basically gets onto the neurons, and they further these propagate these signals to the other connected neurons, and whatever input signals these neurons basically receive, they process those input signals and then activate these the neurons. They can be activated for in order to take some actions or to allow for some decision making process to basically happen. And artificial, when we talk about artificial neural network, it is basically we are trying to build or mimic the human brain neural network in an artificial manner. That is what ANNs are basically. So these are basically nothing but the mathematical model for learning inspired by the biological neural network. So we try to mimic the behavior of the natural way of the neurons working in humans, and we try to incorporate the same working in our artificial neural networks. Basically, we try to develop some mathematical models which should be capable of evaluating some given function as per the given problem. The given problem might be having some input parameters, and this mathematical model will take all those input parameters and then try to come up with some output value, so that with that output value we should be able to take our the decisioning process, or some give some output value that should be helpful in evaluating some results basically. So artificial neural networks, in this they model the mathematical function from inputs to the outputs based on the structure and parameters of the network. And they also allow for learning the network's parameters based on data. So these mathematical functions, they take some inputs from the given the problem in the environment, and they process these inputs to the outputs based upon the available parameters, or the parameters we need to evaluate or decide which are there in the given network. Also, these artificial neural networks, they allow for the learning of networks parameters based on data. So whatever the data is available to us in machine learning, you have a lot of data available with you, right? And you try to configure the network parameters based upon that data, and you try to come up with some efficient model, so that can basically that is more efficient in terms of data loss or the efficiency loss, and it allows you to configure your network accordingly basically. So this is the neuron that is there, actually there in the picture, that is the biological neuron, or connected to some that is basically responsible for propagating the information to the other neurons. And this is the mimic part of the previous this neuron. We will not be we will be representing this biological neuron with the help of some node, you can say. That neuron is basically depicted by this round shape node, and this one node is basically representing the one neuron in working. And further, we have seen that the neurons in the brain, they are connected to other neurons in the network. And similarly, in our network of artificial neural networks, we have the neurons connected among each other. These nodes, or the nodes are representing, the one node is representing one neuron, and the another round neuron, it is representing the another neuron, and they are basically connected among each other with the help of edges. Fine. And x1, x2 are the your input parameters, and you might be with the help of these input parameters, you might be trying to determine whether it is going to rain today or not. So for this, you can devise your mathematical model that can evaluate these input parameters, that is given x1 and x2 parameters, and based upon this you can come up with the solution to the question that whether it is going to rain or not. So this mapping should be there. The mathematical model that we are going to develop, the mapping should be there from that mathematical model to the question that you are basically trying to address basically. Fine. Now this is an hypothesis function. Hypothesis function x1, x2, that takes in the given input parameters in the form of x1, x2, and these are the basically the weights associated with these input parameters. Fine. How you trying to compute this hypothesis function with these x1 and x2 parameters is with the help of this equation, that is where w0 is some the bias value or some dummy value, plus weight 1 associated with the input parameter x1, plus weight 2 associated with the x2 input parameter. So by computing this equation, you can basically try to come at some output value that can help you in solving the question that you are basically trying to address. The w0 is the weight, that is the some bias value that you try to consider, not being multiplied with any input parameter or something like that. And then the weight 1 is associated with x1 input parameter. You multiply it with w1 into x1 plus w2 into x2, and then these are x1 and x2 are your input parameters. Fine. And these are the weights associated, that is marked in the yellow, that is w0 is the bias thing, and w1 is the weight 1, w2 is the weight 2. And this is the step function or the activate function that we basically use when we are using the artificial neural networks. This basically indicates that there has to be some kind of a threshold function that should be there, जो हमें बता सके कि when the value is less than that some threshold value, then the output should be something like this, and if the value is increasing then the given threshold value, then the value should be 1 basically. So this is step function is you can say an activation function, or gx is equal to 1 if x is greater than 0. Now here in this diagram, this is the function is there, that is x is the input here. If x is greater than 0, and if x is greater than 0, now the upper line in the diagram on the right hand side, if x is greater than 0, then जो output है, it gets started it gets starting evaluating to 1, and when this x is less than 0, then this output basically it stays at 0 till your input parameter is less than 0 or less than 0. Till then time the output stays at 0, and once the value increases or it becomes greater than or equal to 0, then output starts evaluating to 1. So that is the step up function basically, fine, or the activation function that basically tells your function that at what point the trigger should be there, okay, or according to what criteria the outputs should be evaluated. So as we were discussing artificial neural networks, these are basically the mathematical models for learning. You can say for learning purposes we are basically devising these artificial neural networks, which are nothing but which mimic the behavior of biological neural networks, fine. And in the process of computing values from inputs to the outputs based upon the structure and the parameters of the network, fine, whatever the inputs are there, whatever the weights we are going to choose, these are all basically we need to consider in order to allow our mathematical function to calculate the values basically, fine. For example, you might be given some two parameters like x1 and x2, and you might be trying to predict the rain. That is what we were discussing previously. Now this was we were discussing now. The x1 and x2 might be some inputs about the weather, whether it is x1 is cloudy, or x2 is the humidity in the air, and based upon these two inputs you try to predict the rain, whether it is going to rain or not. That is the Boolean classification you're trying to do, whether it is going to rain or not, yes or no, in terms of yes or no values. So this is the step function or the activation function that we are basically trying to discuss. This dotted line is before which the output stays at 0. That is in the middle. You might be seeing this dotted line is there. Before this, the output stays at the 0. And once the threshold value increases or reaches at some level, then the output is basically evaluated to 1 basically, fine. Basically the W0, this bias thing which we were discussing in the equation, is it's something basically we use this to bring some function up or down. I will discuss that the bias function in the given examples, and this was the step function that we are discussing. Now various other step functions are there which we can basically use. Another one is this the previous function which we have discussed, it is basically in terms of evaluating the values in terms of zeros and ones, fine. That is in terms of Boolean classification it is trying to evaluate. And another, we might be trying to we might have some values in the output that might be in some range of values, fine. that might be in some range of values. Exact value might not be there. The probability factor where the probability factor comes into the picture, like it might be the probability of having a rainfall of 0.8, or it might be the probability of having the rainfall of 0.4% or 10%, or the real numbered values. Fine. So for those also we need to have some activation functions. One of this function is a logistic sigmoid function, um, given by this equation, that is g of x equal to ex over ex plus 1. Now this logistic sigmoid function, it allows us to have the this values, output values in the range from 0 to 1 basically. Fine. That is, ये जो curve part आप देख रहे हैं, this curve part is there. So this is basically allowing us to have the values in the range of 0 to 1. So we might be interested in some situations in which the output values can be estimated to be in some range of certain values. That's why we might be interested in having some range of values, not in just in terms of 0 or 1. Then there is another activation function is there, that is a rectified linear unit function. Now here also what it is basically considering is this x is an input, and how it is computing is it tries to compare between the given input and the 0. Fine. If it is positive, then it doesn't it remains unchanged, and if it is 0, then the values in the output basically it can differ. Fine. So different functions are there, different activation functions are there by which you can have certain range of values that can be made available to you. Fine. And then the weights are associated, which gets multiplied with your given input parameters. Now this is your input parameter, that is x is your input parameter, and the weight it basically gets multiplied with the given x input parameter, and then you try to compute the given values basically. Fine. So as long as the value is 0, the output stays at 0, and as the value becomes greater than 0, so accordingly that output is basically getting generated. How it is different from the previous one is this was the Boolean classification, that step function that was evaluating the output in terms of Boolean classification, either 0 or 1. Now here in this, till when it is greater than 0, accordingly the output is getting varied. Now this slope is there, that is giving the output in the form of a range of values basically. So depending upon the situation or depending upon the question that you're trying to address basically, so you can bring in the different activation functions, or so that you can address your problems accordingly. Fine. Now this was the equation that we were discussing, that is hypothesis function with x1 and x2 as a parameters, and w0 is basically the bias function. X1 again as an input parameter, x2 as your input parameter, w1 multiplied with x1 and w2 multiplied with x2. Now overall what's happening is, whatever the function g of x we are calculating, whatever we are trying to calculate, that basically goes through this now g of x function. Fine. Whatever input parameters are there, x1 and x2, you consider those input parameters, and you compute that value of w0 plus w1 x1 plus w2 x2, and you let it pass through some g of x function that basically gives you the output that is being desired. Fine. Now in terms of this diagram, if we try to see now what is there in this is, these are your x1 and x2 parameters. X1 and x2 inputs are there, and here in this, the edges are there, which are leading to this output neuron. Now, W1 is the edge associated with the input parameter X1, and W2 is the edge which is associated with the input parameter X2. And here the function that you're trying to evaluate is G of W0 plus W1 X1 plus W2 X2. Now this is the weight parameter with this edge. This is the W2 weight parameter associated with this edge, that is the connecting edge. And it gets multiplied by this X2. And this weight W1 basically gets multiplied by this input parameter X1. And this is the evaluation function, that is G of here on this output parameter, the bias will be acting. This bias function will be acting, which basically tries to bring up or bring down the whole function basically. When there are situations in which we can randomly choose this bias functions and accordingly try to solve the our equations basically. Fine. And this is one example is there. Now, like we have we are familiar with this OR function, right? Now how it works is we have X and Y as an input parameters, and evaluation function is there. Fine, that is OR. F is the OR function that is working in process, and X and Y are the input parameters. So 0 and 0 when are the inputs, the output stays at 0. When the X is 0 and the Y input is 1, the output changes to 1. When this is 1, this is 0, output again changes to 1. And when both are 1, the output stays at 1. So यही चीज अगर हम artificial ANN से हम अगर solve करना चाहें तो how that is possible basically. Now this is the general architecture. General simplest ANN network that we can see is you have given two input parameters X1 and X2. W1 and W2 are the weights associated with these X1 X2 parameters, and this is the bias function and this is the evaluation function. Fine. And यहाँ पे हमने bias को हमने मान लिया -1. The bias function is having the -1. ये जो W0 weight 0 is assigned the value -1, and we are considering the W1 and W2 with the values 1, 1 here. Fine. So this is the activation function, or the function which we have seen here. That is this one, the step function. So this is the step function for this OR function. When the value is 0, that is the threshold is less than or equal to 0, then जो है आपका ये जो output है, it stays at 0. And if the value is greater than 0, then the output will change certainly to 1. तो यहाँ पे जो हमने देखा था, इसमें हमने boolean, ये जो था हमारा ये boolean in terms of boolean output ही दे रहा है ना, ये वाला जो step function है, either it is giving 0 or 1. तो जो हमारा OR function है, that is also working in terms of zeros and ones. That is जो output है आपकी, वो output आ रही है आपकी in terms of zeros and ones. So we can use this function here ना. That is why we are using this function here, this one. Fine. So अगर हम कोई उसकी सिनेरियो हम कंसिडर करते हैं, उसका ये दिस इज द सिनेरियो दैट वी आर कंसिडरिंग. 0 0 है, ठीक है. अब 0 0 अगर x1 x2 है तो हमारी आउटपुट क्या आनी चाहिए? हमारी आउटपुट जो है 0 आनी चाहिए ना और फंक्शन में. तो उसी को हम यहाँ पे कंसिडर कर रहे हैं. अगर हमारी इनपुट जो है x1 x2 है, ठीक है, तो अब यहाँ पे देखें -1 हमने बायस लिया, W0 1 हमारा जो है ये वेट 1 है, और यहाँ पे 1 जो है वेट 2 है, ठीक है. और x1 क्या है 0 और x2 क्या है 0. तो ये इट बेसिकली गेट्स वैल्यूएटेड टू -1. ये जो हमारा उसमें है दिस पिक्चर डॉट हेयर इन द राइट हैंड साइड, जो बॉटम लेयर है -1 के ऊपर ये जो डॉट शो कर रहा है, तो दैट इज, ये जो पूरा फंक्शन है हमारा जी, दिस वन जी ऑफ -1 + 1x1 + 1x2, ये वैल्यूएट किसको हो रहा है, वैल्यूएशन इट इज बेसिकली गेटिंग वैल्यूएटेड टू -1 ना। x1 की वैल्यू क्या है, 0 है, x2 की क्या वैल्यू 0 है, तो ये पूरा एक्सप्रेशन इट गेट्स वैल्यूएटेड टू -1। तो -1 कहाँ पे आ रहा है, यहाँ पे आ रहा है, तो ये थ्रेशोल्ड वैल्यू से लेस है, थ्रेशोल्ड वैल्यू हमारी ये है ना, या ये 0 है, तो इट इज लेस देन दिस थ्रेशोल्ड वैल्यू। तो टिल द टाइम जो हमारी जो आउटपुट आ रही है, इफ इट इज ये जो वैल्यूएशन फंक्शन की जो वैल्यू आ रही है, इफ इट इज लेस देन दिस थ्रेशोल्ड वैल्यू, देन द आउटपुट स्टेज एट 0। तो यहाँ पे आउटपुट क्या रहेगी हमारी, 0 रहेगी। अगर इवैल्यूएशन फंक्शन की जो वैल्यू है वो ग्रेटर देन थ्रेशोल्ड वैल्यू है, देन जो हमारी वैल्यू है दैट बेसिकली गेट्स कंप्यूटेड टू 1। तो यही हमारी आउटपुट थी, आउटपुट है 0 है, तो 0, ये जो हमारा ANN नेटवर्क है दैट इज ऑल्सो कंप्यूटिंग द वैल्यू 0 बेसिकली। सेकेंड केस हम अगर कंसिडर करते हैं उसका और का, अगर हमारा 1, एक इनपुट 1 है और अनदर इनपुट इज 0, उस केस में हमारी जो आउटपुट है वो क्या होनी चाहिए, 1 आनी चाहिए। तो उसको सॉल्व करने के लिए हाउ वी कैन द सेम आर्टिफिशियल नेटवर्क ANN जो हमने डिस्कस किया है, सेम ANN वी कैन यूज बेसिकली। हाउ दिस इज हैपनिंग इज x1 is 1 here, x2 is 0 here, and just a second. This is the case. X1 is 1, x2 is 0, and this expression becomes W0 value की वैल्यू क्या है, -1, और this x1 1, ये भी 1 है, ये भी 1 है, it becomes 2, 2 - 1, it becomes 1। तो ये जो पिक्चर डॉट है that is indicating the value, this 1 वैल्यू। तो जो हमारी आउटपुट होएगी वो क्या आएगी, इट विल बी 1, क्योंकि थ्रेशोल्ड से बढ़ गई है ना वैल्यू। तो दिस बेसिकली इट विल बी बेसिकली रिस्पॉन्सिबल फॉर हैविंग द आउटपुट एज अ वैल्यू 1। ठीक है, ये अब हमारा क्या है, अगर हम दोनों ही उसमें और फंक्शन में द इनपुट वैल्यूज आर 1 बेसिकली, उसमें क्या हो रहा है, -1 + 1 × 1 + 1 × 1, तो ये क्या होएगा आपका, पिछले केस में हमारा 0 होएगा ना, ये पिछले केस में हमारा ये 0 हो रहा है ना, ये तो 0 हो गया, 1 × 0 0 + 1 × 1 1 और -1, ये 0 हो गया ना, ये यहाँ पे 0 हो गया। तो this, or if we have reached the threshold value, then our output is basically 1। ठीक है, जो करेक्ट आउटपुट है एज पर द और फंक्शन। उसके बाद अगर हमने ये सिनेरियो चूज किया है कि दोनों ही हमारे 1 है, इनपुट पैरामीटर्स x1 भी 1 है, x2 भी 1 है, जब इसको हम इवैल्यूएशन फंक्शन को हम कंप्यूट कर रहे हैं, वो क्या कर रहे हैं, -1 + 1 × 1 + 1 × 1, दैट इज 2 - 1। ठीक है, तो इट बिकम्स 1, इवैल्यूएशन फंक्शन की वैल्यू क्या आएगी, यहाँ पे 1 आ रही है, इट इज सर्टेनली ग्रेटर देन दिस थ्रेशोल्ड वैल्यू, सो दिस बिकम्स the output basically again stays to 1, that is what is desired from our OR function। ठीक है, so this you can see basically with the help of this simple artificial neural network, how you can basically solve this OR functionality, simplest network। Similarly for this AND function is there, you have this all these possible 4 input scenarios। ठीक है, you have these different 4 set of input parameters and the values accordingly, both are 0 then 0, till the time you don't have both inputs as 1, till in all those scenarios the output will be 0, and for the value should be 1, both the parameters has to be 1। ठीक है, वो हम वही है हमारा जो स्टेप अप फंक्शन हम वही यूज कर रहे हैं ठीक है। और यहाँ पे हमने जो बायस W0 है उसकी वैल्यू हमने ले ली है -2। फाइन, आई हैव ऑलरेडी, हम डिस्कस कर रहे थे कि द W0 वैल्यू इज बेसिकली यूज टू मेक अप और डाउन द फंक्शन। यहाँ पे हमने उसको और डिक्रीज कर दिया, -2 कर दिया। पहले केस में -1 था, यहाँ पे -2 कर दिया। अब the weight values remain the same, x1 remains 1 and this weight 2 value, it remains again the 1. Weight 1 value is 1, weight 2 value is again the 1. Now x1 is 1, x2 is 1, तो ये फंक्शन हमारा क्या evaluate होएगा, 1 into 1 1 plus 1 into 1 1, ये 2 बन गया, 2 minus 2 becomes 0, तो ये थ्रेशोल्ड वैल्यू पे हमारा पहुंच गया। थ्रेशोल्ड वैल्यू 0 इज देयर एंड हमारा जो आउटपुट है दैट शुड बी 1। बेसिकली चेंज हो रहा है ना, यहाँ पे चेंज हो गया। स्टेप फंक्शन इज कहाँ पे आपका जो आउटपुट है वो चेंज होएगा, दैट इज व्हाट इट इंडिकेट्स। अब यहाँ पे थ्रेशोल्ड वैल्यू पे हमारा जो है वैल्यू जो है वो पहुंच चुकी है। नाउ द आउटपुट विल चेंज टू दिस 1 वैल्यू। Another scenario is when x1 is 1 and x2 is 0. तो अगर इस g of x को हम पूरे को इवेल्युएट करते हैं तो हमारा वैल्यू क्या आएगी, -2 plus 1 into x1 1 plus 1 into x2 is 0, that is -1। ये पूरा एक्सप्रेशन -1 को इवेल्युएट होएगा ना, तो -1 इज देयर जहाँ पे ये पिक्चर डॉट शो हो रहा है, तो इट बेसिकली बिकम्स इक्वल टू 0। So that is what was required, यहाँ पे 0 आना चाहिए ना, that is what our step function is indicating, that is the 0 value is there। and this is, I mean, so this examples that we were discussing, this was in terms of zeros and ones, fine। Now there might be some more complex cases, more complex scenarios can be there in which the probabilities of the outputs might be evaluated in terms of probability, like you have humidity and pressure factors into consideration, and based upon that you are trying to compute the probability of the rain। So again another scenario is there, advertising factor is there and the operating month factor is there, and you're trying to predict the sales factor, what could be the sales factor in the given current scenarios। So these are quite complex scenarios in which you are trying to figure out the probabilistic values of the output factor basically। And also what we have discussed earlier is we have taken two parameters, x and y, and they are going to one output parameter, but in some situations there might be more than one parameters also। It is not necessary that only x1 and x2 will be there as an input parameters. It might be there that number of inputs will be there and they might be connecting to the output edge। And similarly for this also, you number of inputs might be there connected to an output edge। And what is the general equation for the calculation is g of W0 plus W1 x1 plus W2 x2, that is what we have seen in the previous cases, x1 being the first input parameter, x2 being the second input parameter, and W1 and W2 are the weights associated with those inputs। And x1 x2 x3, now this is the scenario in which the inputs can be more than two, like x1 might be the one input, x2 might be the another input, and x3 might be the another input, and W1 W2 W3 might be the weights associated with these inputs। And this is the equation that we use, W0 is the bias function, and Wn x1 plus W2 x2 plus W3 x3, that is summation of all the this multiplied factors, W1 x1 plus W2 x2 plus W3 x3। Now here we are seeing that the inputs increasing to n number of factors from x1 to x5। So this function basically resolves to g of summation of from 1 to 5, that is considering all the input 5 parameters multiplied by the weights associated with these input parameters and plus this bias weight value. The same thing is there. We have just resolved it into this expression, that is summation of all the multiplied factors, the input parameters with their respective weights associated with them, and plus the bias function. So this is for n values. If you are given n input parameters and the n edges connected to the single output neuron, then what can be the equation? So summation of from all the values from 1 to n, and then this bias function, that is W0. Now, another factor is there, that is when we are trying to develop our artificial neural networks, or when we are trying to design our ANNs, we should consider we should try to minimize the loss when we are basically trying to train our this artificial neural networks. Now, how you can do that is with the different approaches are there. One of the approaches is gradient descent. What is this? It is basically an algorithm for minimizing the loss when you're trying to train your artificial neural network. So you start with what is the basically approach in there is in the gradient descent is you start with some random choice of weights. Fine. And you repeat. Under repeat, you basically calculate the gradient based on all the data points and the direction that will lead to the decreasing loss. Fine. So you consider all your input parameters, you consider all your the weights associated with those input parameters, and then you calculate the gradient based upon all the data points. You are basically here considering all the given data points available in your environment, and you try to observe the direction that is basically that will lead to decrease in the loss function basically. Fine. And the loss function is basically you can say that associated with the performance of your artificial neural network, that is how close you are to some desired value, or how close you are to some accurate value. In order to reach that the value more accurately, you try to minimize your losses. So that is how you do that with the help of with this calculus approach, that is the gradient descent algorithm is there. Basically how to set weights in a proper manner so that your neural networks can model so the given function more accurately. Fine. So this is the algorithm for minimizing the loss when we are training the neural networks, and we basically it is basically more or less associated with an slope. Okay, the direction in which our weights should move. Basically, we try to observe that slope thing basically. So that how you do is you start with a random choice of weights, and then you try to repeat this procedure of observing all the data points, and you try to observe the direction that leads to the decreasing loss, and then you update the weights according to that direction basically. ठीक है, जो आप direction observe करते हो उस direction के accordingly then you try to update the weights according to the gradient basically. Now यहाँ पे हमने use किया है all data points. Now this approach can be quite heavy when you are trying to solve some machine learning problems. As you know that there is an whole aggressive availability of data points when you're trying to tackle some machine learning problem, and when you're considering all the data points, then I mean you are quite using huge set of data points, and that can basically lead to trade-off. It can be in efficiency and the time trade-off when you are considering all the data points. Okay, so that is why this is being highlighted. The procedure remains the same. You start with a random choice of weights and then you repeat, and that is the calculate the gradient based on all the data points, direction that will lead to the decreasing loss, and update the weights according to that direction. Now to overcome that approach, you have another approach is there, that is stochastic gradient descent. पिछले में हमने all the data points we are considering. Now here in this stochastic gradient descent, you basically calculate the gradient based on one data point. So वो जो एफर्ट है वो मिनिमाइज कर रहे हो, जहां पे आप सारे डेटा पॉइंट्स कंसिडर कर रहे थे, वहां पे आप you choose only one data point, and accordingly you try to update the direction in which you are trying to move your weights basically, and then you update the weights according to the gradient. Obviously यहाँ पे भी trade off है in terms of accuracy and this space or the time requirements. Obviously, when one data point is there, you have the chances of getting that much of an accuracy will not be there. So that is the thing here in stochastic gradient descent. And another one approach is that is mini batch gradient descent is there. Now here in this, you choose some batch, one small batch is there. Under the repeat procedure, you calculate the gradient based on one small batch, the direction that will lead to the decreasing loss, and then you update your weights according to that direction. So these procedures are there which try to overcome the trade-offs between the accuracy and the other requirements that might be burdening the system. So the trade-offs are there. Fine. So then we were actually in the previous cases, we were seeing this kind of artificial neural networks, simple input parameters connected to the one output parameter. Now there might be scenarios might be there where you have one input associated with more than one output values. So that situations are there. Now here you might be seeing that all these three input parameters are associated with the two output parameters, and each of the input parameter is having two edges associated with the output neurons. Now here in this, you have each input parameter is associated with all the four output nodes, and each input node is having the edges connected with all the output nodes basically. Now you might be given some parameters, and based upon those parameters you might be trying to determine about the environment, that is whether it is rainy, sunny, or cloudy, or snowy. So different output values can be there. So you also need to model all these parameters accordingly. So inputs is there, then weights come into the picture, and then you try to output the values according to these four different parameters. And this probability values can be there, 0.1, 0.6, 0.2. There might be the probability of raining, that is 10%, or there might be the probability of having a sunny day of 60%, and then so on. So this is so these are the actions basically that will be getting activated as with respect to the input parameters or the weight parameters that we have in our given scenarios. Fine. Now here in this, the same output node is getting the inputs from all the three nodes that you might be observing that. Now here in this, second output node is getting input from all the three input nodes, and similarly third and fourth output node is having the input values from all the three different nodes. So what we are trying to make a point here is you might be having a number of different scenarios when you are trying to work with artificial neural networks. You might be having number of inputs there, number of outputs there, n number of associations between these inputs and outputs, and then you need to devise your ANN model in such a way that it considers all the input values and the parameters accordingly, and will give you the desired solution, right? So these are the possibilities that further also we will be discussing that and taking into the consideration. Any doubts are there, you can ask. Any queries are there? Oh, now the students have joined. Any queries are there? Yes? Any queries, beta?